Hello students, this is Mr. Keener here. I'm going to be doing my best Kirk Weiler impression to teach you guys this topic today, function evaluation and notation. And thank you guys for watching. Remember to like, comment, and subscribe. You're all letting me fulfill my dream to become a famous internet celebrity. I'm so excited. Alright, let's go ahead and get started. So, in the previous lesson, you learned about what a function is and a little bit more about it, some function notation. So just a quick review, a function is a rule that produces one output or y value for every input or x value. So the set of outputs are called the range, and the set of inputs, x values, are called the domain. And these domains and ranges and all of the different solutions and pairs of x and y values can be displayed on a graph, like this one here. So this is a quadratic function. We don't know the exact function, but we do know that there are a bunch of inputs and a bunch of outputs. And this question is asking us to find all of the x values, here we go, all the values of x where f of x equals -5. So we remember from the previous lesson that f of x is the same as y. So really this is asking what are all the values of x when y is equal to -5. So y is equal to -5 right here. This is -5. So if we were to go ahead and draw a horizontal line at y equals -5, everywhere that this quadratic function crossed that horizontal line would be our x values. So this point here and this point here. So we can see that the x values where y is -5 is -3 and 1, and that's our answer to that question. So find all values of x. That would be when x equals -1. Oops, my mistake. When x equals -3 and +1. All right, input, output. Input is the x value, output is the y value. All right, let's go on to the next problem. Example 2, the graph of y equals f of x is shown below. So we don't know what the rule is, but we do know that this is a linear function because this is a straight line. Find the value of f of -1. So remember, f of x is our notation, and x is our input. So if the parentheses, or what's in the parentheses, is replaced by -1, that means that -1 is my input. So if -1 is my input, my x value, then what is my output? Well, that would be the y value at that particular point on the graph. So if we put in -1, we get out -2. So f of -1 is equal to -2. All right, we're cruising. Let's keep going. Example 3, evaluate the function f of x equals -x squared plus 3x plus 13. So in the previous example, we talked about how whatever's inside the parentheses is the input. An easy way to evaluate a function algebraically is to just take whatever's inside this parenthesis and just replace x. I don't know, I just crossed out x with an x. That was a little redundant. Just replace x with that value. So in this case, we are going to do -10 squared. We're going to put it in parentheses just to make sure that we know that the negative is involved. We're going to do plus 3 times -10, and notice the appearance of the parentheses again, and then plus 13, and that stays the same because there's no x value there. Now from here, to find our value of f of -10, we're just going to evaluate this statement using our order of operations. So let's go ahead and move this stuff aside so we can get back to it. -10 squared is 100. -10 times -10 is 100. And this is where it gets kind of interesting. Because this negative was outside of the parentheses right here, we're just going to go ahead and take our result, our 100, and we're just going to make that negative. So this is going to become -100 because this negative was outside the parentheses, meaning we do this -10 times -10 first, which negative times a negative is a positive, and then we take the negative here. And then we're going to do this one. 3 times -10 becomes -30 or -30. And then 13 just stays the same, plus 13. And then from here, we're just going to do some math. -100 minus 30 becomes -130. And then -130 plus 13, just going in order here from left to right, is going to give us -100 and, oops, messed that up. Oh wait, no I didn't. -117. -117 is our answer. So what we say is f of -10 equals -117. All right, so just like that, we take what's inside the parentheses, we substitute it in everywhere we see x, not just once, but everywhere we see x, and then we evaluate using our order of operations. All right, let's move on to example 4. Oops. House burning down. The dangers of quarantine. It's okay. It's taken care of. All right, no worries. All right, given the functions f of x, given the functions f of x equals 4x cubed and g of x equals 2 to the x power, which of the following statements is true? All right, so functions are normally described with the letter f for function, but they can really have any name you want. So in this case, it looks like they gave them the name g. So we've got two different functions. That's the key here, two different functions. One of them has this rule, and the other has this rule. And what this question is asking, if we were to evaluate each of these functions with an input of 15, how would the outputs be different? So we can see that 15 is put in each time. So let's go ahead and just put 15 into each one. So f of 15 is going to equal 4 times 15 cubed. And g of 15, because this is a different function rule, is going to equal 2 to the 15th power. All right. Now, you can use your calculator for this, or you can reason about the types of functions these are. So 2 to the 15th power is going to give you a massive, 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 massive number. 15 cubed is also going to be a pretty big number. Let's go ahead and pull up the calculator and take a look at it. 15 cubed is 3,375 times 4 is going to be 13,500. Okay, big number. But when you have 2 to the 15th power, the more practice you have with these types of exponential functions, you can really start to see how big these numbers get. So 2 to the 15th power, 32,768. All right. I guess not as big as I predicted. It's okay. Slight disappointment, but still very big. All right. So when we plugged in 15 to f, we got 13,500. When we put 15 as an input for g, our output was 32,768. So if we are to compare our two outputs, we can see that our output for f of 15 is less than our output for g of 15. All right. Example 5. Evaluate the function f of x equals negative x squared plus 3x plus 13. All right. So remember when I said whatever's in the parentheses, that's what we're going to substitute in for x? Well, it doesn't change if we have an expression in the parentheses. The rules are all still the same, even though we're dealing with letters versus numbers. And honestly, what are numbers anyway, rather than just symbols that represent values? Guess what? That's exactly what variables are. So why would the rules be different? They're not. It all works. I love math. All right. Negative x plus 1 squared plus 3 times x plus 1 plus 13. Just like that. And from here, we're just going to simplify. X plus 1 squared is going to give us x squared plus 2x plus 1. I can do that in my head because I'm a math teacher. I'm going to take the negative of that, plus 3x plus 3 plus 13. Go ahead and distribute this negative. Make sure you're maintaining the integrity of your parentheses here. If we have parentheses, then we're going to go ahead and distribute that negative to everything that's in the parentheses after we do it. So it's going to be negative x squared minus 2x minus 1 plus 3x plus 3 plus 13. I apologize if you had a tab down at the bottom that you have to move now. No, I'm sorry. I'm not sorry, actually. I'm going to extend the page and keep going upwards here. I know it didn't work. Hold on. There we go. All right, more space. We're just going to combine the like terms. Negative 2x and 3x become x. Negative x squared has no like terms. Negative x squared plus x. Oops, that's a funny looking plus sign. Oh no, I've ruined everything. Apologies. Plus x. And then negative 1, 3, and 13. Put all those together and you're going to get 15. And that is our answer. So f of x plus 1 becomes negative x squared plus x plus 15. Interesting. I don't know if that's what you're expecting to get, but that is what we got in the end. So there we go. Negative x squared plus x plus 15. All right, moving on. Last one. Given the function f of x equals negative x minus 2, then what is 2 times f of x as a simplified polynomial? Okay, let's talk about what we see here. 2 times f of x. So a function often we see by itself on one side of the equation, but remember that you can treat a function as if it's an entire expression. Algebra is all about substitution. This equal sign says, hey, whatever's on one side of the equation, we can substitute the thing on the other side of the equation wherever we see that. So if we see f of x equals negative x minus 2, then wherever we see f of x, we can write negative x minus 2 instead. Maybe think about it this way. If f of x is y, that means y equals negative x minus 2. So if we were to do 2y, well, it's marginal to just go ahead and substitute negative x minus 2 in for y. And that's what we're going to do here. 2 times negative x minus 2, we get negative 2x minus 4. And that right there is what we get, 2 f of x. We're just doubling the function right there. Equals negative 2x minus 4. And that is a simplified polynomial. All right. Well, that's it for today, kiddos. Do your homework. Stay safe. Enjoy your time off. And take care. Brush your teeth. All right. Bye-bye.